Now we want to look at how to use the Nspire to do paired data and one sample T procedures. In this experiment, researchers wanted to find out if caffeine deprival led to depression. So they randomly assigned patients to either take a caffeine pill, first of all, not to use any other caffeine source, but either take a caffeine pill or a placebo, and then they would test their level of depression at the end of each 2-day period where they had either had caffeine or had placebo. So we have the results here of the depression tests after they'd had the caffeine, after they'd had the placebo, and then the difference. So basically the null hypothesis is going to be that there is no difference, that the difference would be 0 between whether they'd had the placebo or the caffeine. If placebo minus caffeine has a positive difference, then that means the caffeine is actually then being deprived of the caffeine is a problem. In other words, they're having a higher rate of depression with a placebo than they are with the caffeine. So we have here that the mean of the differences, so we're actually looking at the mean of the differences being 0, or the mean of the differences being greater than 0 as our alternative that we're trying to find evidence for. So if we look at the condition, I do want to point something out. The random condition here isn't that we randomly selected subjects, because that's very rare in an experiment. It is that we randomly assign the treatments. Also, we do not check the 10% condition because we aren't sampling. So don't say that 11 people is less than 10% of all of the population of people that might be caffeine dependent, because that doesn't make sense in this situation. We're not doing that. Now, we do have to check. We have a very small number. We don't know whether the actual distribution of people that are caffeine dependent and their depression scores would be normally distributed. So we do have to check on the calculator for this condition. So let's go ahead and look at what we've got here. So I wanted to show you basically, first of all, if you were given the 2 sets of data, how would you find the difference quickly on the calculator? So I would name another list difference. Then I'm going to say equals, and then if I go to my variable button, I'm going to find the placebo, and then minus, and then go to the variable button and find caffeine, and then push enter, and that lists all the differences in this third list. And this is the list that I'm actually going to do the test on. It's a test of the differences, not a test on either of these individually. So first of all, going to a data and statistics page, I'll double check the graph to see if this is an appropriate set of data on which to do a t-test. Kind of hard to tell with this one. It doesn't look like there's any obvious skews or outliers, but if I made let's do a histogram here, and notice the bars are usually too small when you first make the histogram. So if you hover your cursor over the edge till this little bar with 2 arrows on, hold down until the hand closes, and then just drag together. Okay, so notice here I've dragged together so I have bars connecting. So looking at this, it's a little bit right skewed, but nothing so severe that I would think this would be a problem. If I'm not sure, then I'm going to check the normal probability plot, because that can sometimes help with a small set of data, like these are only 11 points. So normal probability plot. Yeah, once again, fairly straight, not a real problem. So I can say that it's okay to use the T model, that condition is satisfied. So now I'm going to go to a calculator page and do my t-test. So menu, statistics, stat test, a t-test. Now notice I'm not doing a 2-sample t-test, I'm just doing a t-test because I'm using only the differences in my test. So my null hypothesis is there is no difference. The differences are 0. The list is the list of differences, and then my alternate hypothesis is that the difference is greater than 0, which would give evidence that placebos people have more depression than the caffeine people do. So here we go. Now here we have a really small p-value here. Our t, our test statistic, 3.53 standard deviations from the mean. p-value less than 1%. So we have here convincing evidence to reject the null hypothesis because the p would be less than 5% or even less than 1%. So we have convincing evidence that the difference in depression scores for the people who took the caffeine and the placebo pills is not 0. In fact, we have convincing evidence that it's greater than 0, that people who took the placebo tended to have higher depression rates. So let's kind of go back here, look at this. So you see here the test statistic, and let's see how it's computed by hand. All right, so here's our test statistic. Notice that we get the x bar of the differences, and the standard deviation of the differences would be from our calculator results here. So there's x bar. That's x bar and standard deviation of the differences because I used the list differences when I calculated it. So this came from the differences. And I have my p-value and my t already calculated. And let's see here. I don't know if we have, yeah, here's, because the p-value of 0.0027 is less than alpha's 5%, we reject the null hypothesis that the mu of the differences is really 0. We have convincing evidence that the true mean difference, placebo minus caffeine, and depression score is positive for subjects like these. Now realize this little last part is because we can't generalize these results to all people, but only people maybe similar to those who took part in the study, those volunteers. So at least we know that this difference is significant, is statistically significant.